everyone. Thanks for coming. This is the deep dive on microservices and ECS. I've gotten many strict warnings about making sure that I start very promptly on time. So we're going to go, even though people are still filing in. My name is Abby Fuller. I'm a technical evangelist. I work for AWS. Technical evangelist is really just a funny way of saying that I am a regular software engineer, and I talk to people at conferences now. So here we go. So just to level set, what are we going to talk about? So our first one is we're going to take it a step all the way back, and we're going to talk about what are microservices. We're going to do a lightning ECS overview. We're going to get feature specific and talk about two pretty specific features. We're going to talk about flexible orchestration in ECS. We're going to do a quick fake demo on container lifecycle with the ECS CLI. And then we have a special mystery guest. It's not a mystery anymore because the session has already started. But Peter from TravelX will be joining us to talk about how they use ECS in real life at a real company. So let's get rocking so we can finish promptly. So what are microservices? And I added this a little bit ago, and it wasn't in the regular deck, but I figured that we had to go one step back, right, and figure out, well, we're orchestrating these containers, but why are people using containers in the first place? So what makes these a good architecture fit? So this is the favorite definition of microservices at AWS. And we used to say that Adrian was the best AWS evangelist that didn't work for Amazon. But he works for Amazon now, so the joke isn't as funny. But it's still a good definition. So what are microservices? So it's a service-oriented architecture composed of loosely coupled elements that have bounded context. And this sounds really nice, but what does this mean? So it means that we've broken down our services. Each one of them has a very specific job. They are loosely coupled. So they talk to each other, but they talk only over the network. They each have a job. And deploying to one service should require zero knowledge of another service. So in practice, if I'm a developer, I'm working on my services, me being able to deploy a messaging service should not require that I have any knowledge of like an admin dashboard. So they are loosely coupled, they have bounded context, they have one job, and they do it well. And in most cases, you separate them on the service level. So I might have a messaging service, or an admin app service, or a graph service, something like that. So that's our definition. We're going to stick to it. There are many like it, but this one is my favorite. So this is a topic that I think we've seen a lot in very trendy Medium posts recently. I also wrote a trendy Medium post on this, so cool. But the whole monolith to microservices. So a couple years ago, a lot of people weren't doing microservices. You had your monolith. So you had, OK, I work for my company. I work on my company's service. I push it to a GitHub repo. I deploy that service, so that repo, on many different servers. And I load balance, maybe, if I'm lucky, between those servers. So what happened with microservices? So when did we break off from kind of this one big monolith architecture to these little microservices? And what this means is if we go back to our definition, we based it on service. So before, I might have my giant web server service, but now I'm breaking it up into, I have a UI, I have my ordering service, I have my inventory service, I have my shipping service. So we've broken up that one big monolith into separate services, and each one of them has a very specific job. They speak to each other only over the network, so via a public API, and they are loosely coupled. So I should be able to deploy to my order UI without knowing how the shipping service works. So let's talk about, other than being loosely coupled and service-oriented, let's talk about some characteristics of what these microservice architectures look like. So this is a really pretty diagram. I actually did not make this one, although it looks like something I would make. It is just circles. What are some characteristics of what these microservices look like? So they're independent. A lot of these, right, they're really similar to what we looked at with Adrian's definition. So they're decentralized. They're polyglot. So if I have a Node.js service, it shouldn't prevent me from having a Python service or a Ruby service. They do one thing well. And this is my favorite, I think, because I have a lot of people, they start talking to me, and they're like, well, my microservice isn't so micro anymore. And if you find that your microservice is doing many jobs, so maybe it's handling shipping, and maybe you added some features, and now it's handling your orders also. Maybe it's time for your big microservice to become two little microservices. So you make sure that you're decoupling those, that you're keeping them very service-oriented. I was a former ops person before I came to work at Amazon. So I changed my mind, and maybe this one's my favorite. But you build it, you run it. And it used to be something that if I worked on a service as a developer, I could throw it over the wall at DevOps. And I could be like, well, I wrote this, and if you're lucky, there are tests. But someone else's problem to be on PagerDuty and to be on call and to make sure that this works. And now, you build it, you run it. So with microservices, I can work on my service all the way from my local development environment to running that in production. And that means I'm responsible for it. I write the tests for it. I know everything about how that works. So I'm a part of my infrastructure, from my architecture, from my process, from the ground all the way up. So how do I run these microservices on Amazon? There are many ways to do it. My favorite, spoiler alert, is ECS. So that is Amazon's EC2 container service. Let's talk about more exciting things. So what is ECS? So I think the kind of the overarching definition here. So highly scalable, high performance container management system. So what this means for you in practice is eliminates the need to install, operate, and scale your own container management infrastructure. So there's some trade-offs, right, to microservices. So if I have my monolith, I only have one thing to worry about. And I might have to deploy it on many services, on many different servers, but I only have to worry about that one monolith. And that is not the case for microservices, especially when we've separated them, as is pretty logical, into these containers. I have to worry about orchestrating, deploying, managing, and scaling a lot of separate pieces now, where before I only had to worry about one. So where ECS comes in is how can I scale and manage and operate those without having to worry about some of the little pieces. So a managed way to get deep AWS integration, to orchestrate these many containers, and to manage the resources of your cluster. So how do I deploy things? How do I scale it? How do I take care of all these little containers so I can focus on running my application and less about, do I have enough containers? So I added this one. So I think one of the most common questions that I've gotten about ECS is, how does this map back to traditional workloads that I'm familiar with? So ECS sounds great and containers sound great, but how does that tie back to kind of AWS terms that I'm familiar with? So here's a diagram. I made it myself. Instances in ECS. There are no secrets. They are standard EC2 boxes. So once you register them to an ECS cluster, your tasks run here. A service is a layer that manages and places tasks. So that's it. And then a task is just a wrapper and configuration layer around processes running on those instances. So it sounds a lot less secretive, I think, when you do it this way. So yeah, there's containers, and they're running on a cluster, and you register them as part of tasks. But this is all that it maps down to. This is just a different way of managing your processes across your instances in a way that works really well with microservices. So who is using ECS? That purple air logo was also me. But I promise there are other people that are using it too. Some really cool companies out there writing cool posts, doing cool demos. We're going to hear from one of them in just a couple minutes, but check out some of these. Why are people using ECS? So the fully managed part, optimistic scheduling, and then I think when you go back and look at the rocket ship slide about the deep AWS integration, I think this is what people are usually talking about. So there's lots of pieces that go into deploying and managing these containers, but there's also stuff that goes into, if we're smart, into logging and monitoring and health checking and getting the data off of these containers. And where the AWS integration comes in is that I can make that work really easily with stuff like Cloudwatch or with CodeStar products. So I can focus, again, and this is a theme, on focusing on making my application run really well and less about, oh my gosh, does this log right? So we're going to talk about this, I think, in a different kind of way in a couple minutes. But part of what I'm looking for ECS is flexibility. So I should be able to choose how my jobs run in the way that works best for my workloads. So I should be able to either run a long-running app or a batch job. And there's been a couple announcements recently about some different ways to kind of tweak these on resources. But I should be able to schedule a task. I should be able to run a task just once. I should be able to place it randomly. I should also, though, be able to have my long-running apps. And those mean things like my web server, my order UI that we looked at a couple slides ago. I should be able to health check and remove containers that aren't healthy anymore. I should be able to schedule these. I should be able to scale them up and down. I should be able to, in typical Amazon fashion, do this in multiple availability zones. And I should be able to group containers logically based on what they're doing. So for us, that's the concept of a service. So I can scale up my web service, but leave my UI service alone. So let's get feature specific. There are many features that would, I guess, be kind of cool, but we're going to talk about two very specific ones. The first one is task placement, and the second one is about events for Cloudwatch. So I said a couple minutes ago that what this was about was flexibility, and I think both of the features that we're talking about are there for the same reason. And they're there because not only should things work out of the box with kind of sensible defaults, but you should be able to customize how this works and extend on top of it to make sure that ECS handles your workloads the way that you want them to be handled. So part of the way that we can do this is with task placement. So two components to this. A task placement strategy is an algorithm that lets you select your instances for task placement or which ones to terminate. And a constraint is a rule that you take into consideration during task placement. So you use these together. Basically, we can pick on some of these attributes, whether it's an AMI or an availability zone or a custom one like prod, and we can filter our instances and we can place our tasks accordingly. So we can do this in a couple different ways. The first one is bin packing, which is a really fancy way of saying put as many things as possible in the smallest amount of space. So this is resource optimized. So if I want to use the least amount of instances possible, bin packing is the right way. So if I have a couple instances that have space, but one of them has just the right amount of space and the other one has a lot, bin packing will place them as close together as possible so that you can get the most out of your instances. And a spread will let you spread them as evenly as possible around your instances. Random, it's random. I put some question marks in there. So how does this work? So it's just like middle school math class. This is order of operations. You do your cluster constraints first. So CPU, memory, in a lot of cases, port. So if you've been looking at the application load balancer versus EC2 classic load balancer, port is not always a constraint anymore, but for a lot of people, it still is. So you have to you meet your resource constraints first. Once you've met your resource constraints, you filter for location or instance type, those custom attributes, all those things that we looked at a couple slides ago. Then I identify my instances that meet my strategy. So for example, my spread strategy. And then I apply my filter. So I select my final container instance that I want to place my tasks on. So again, it's about flexibility. So I should be able to place my tasks the way that I want them to be placed. And ECS should have a sensible default for me, so I should be able to place my task. I should be able to not think about it, right? If I don't want to write my own placement policy or use a different one, it should work out of the box. But if I want to customize this and use my resources a little differently, I should be able to do that too. Number two, Amazon ECS event stream for Cloudwatch logs. This is a really long name. But ultimately, it's something that's actually really kind of cool. So I can receive almost real-time updates about both the current state of my container instances and the current state of all those tasks, which in practice lets you do a couple of things, right? So I can build my own scheduler on top of ECS, or I can monitor my cluster state changes. And I can consume those events, so it events things like task started, task stopped, task pending. I can consume those with other AWS services, so everyone's favorite and most popular, Lambda. So I keep talking about flexibility. So where is this fitting in with ECS? It's a choose-your-own-adventure thing. So my orchestration platform, so in this case ECS, it should have these sensible defaults, right? So if I'm just starting with ECS and I don't really want to tweak my own resources, or if I'm just playing for a weekend side project, or even if I'm just not an ops person and I want to go from 0 to working app as quickly as possible, there should be sensible defaults. So it should not run out of memory immediately. It should not run out of CPU immediately. It should just have kind of a sensible starting place for me to run a lot of apps. And then on top of that, which is what we've been talking about mostly today, is the ability to extend and customize. So I should be able to pick one or a combination of both. Meaning if I just get started and I use the defaults for everything, I should be able to customize just one of those as I go along. So maybe I bring in a scheduler, or maybe I say, oh, well, you know what? I run out of CPU kind of fast. Let me use let me use the strategies and constraints for my task placement to see if I can use my resources a little bit more effectively. Couple ways to do this. So first off, we have options. So when I'm working with ECS, I can use the console. And before everyone shouts at me, and especially Hacker News, the spoiler alert, I like the console. So why do people use the console? So you see a lot of demos and a lot of talks, and everyone's always using the console, and everyone's like, oh, gosh, why don't you use the CLI? Real developers use the CLI. Why the console? So you'll notice that two reasons are the same, and they're both JSON. Have you ever tried making a VPC and all of its subnets in JSON from the CLI? If you do, never try it again. It was awful. There are reasons that there is a console, and the biggest reason for me is it's quicker to test and get started, and I get visual feedback. If I do something wrong in the console, I get a message telling me in no uncertain terms that I've done something wrong. I can kind of play along what's going. I can work through the first run wizard for ECS, but it's quicker for me to work that way until I know what I'm doing. But the console is not for everyone. So if you're customizing or automating, the CLI is a better choice. There's a couple different options for this. There's actually two CLIs. There's the AWS CLI, which is kind of the familiar one that you can use with a lot of AWS services. There's also the ECS CLI. So still open source. You can pass it Docker Compose files. But both of these, in summary, you can use them to manage your container lifecycles from start to finish. So in keeping with our flexibility theme, you should be able to automate to kind of tweak these, to extend these, to put these in your CI/CD system. You should be able to do all of this. So let's look at the container lifecycle. So our first stop, we have to create a cluster. So with all of these are really basic API calls. In a real-life production environment, these are probably not going to cut it. But for the purposes of our little example, I can create a cluster, and it will return some information. So there's nothing happening in this yet, right? So I have no instances. I have no tasks. I have no services. But I've created my little empty shell. And my shell is where all of my services are going to go. The second stop is I have to create a task. So this sounds, it's a pretty specific order of operations here, right? So I have to have my empty box first, and then I can do all the pieces to put in that box. This is a little counterintuitive for me, but after you create the service, your next stop is creating a task. So I can register my task definition. It's with my favorite JSON. I can pass it a JSON file, though, and not this string, but I could do both. So I've created my task definition, and that's basically saying, hey, describe the service that you want to run. And that's what my task definition is. Then I can use my task definition, and I can create a service. So my service, remember when we looked at that slide where we mapped all the ECS pieces back to our EC2 workload? The service is just managing my task. And what's important here is this is where my deployments happen. So if I want to deploy something on ECS, all I really have to worry about is that desired count or that task revision. So changing the task revision, so going from web app 1 to web app 2, that is a deployment. That is all. So if you're doing this from a CI/CD system, that's pretty easy, right? So I can build it, and I can go from start to finish. So I build locally, I push to my CI/CD system. So that's a commit tied to a build number in a CI/CD system, which is then tied to a task revision in ECS. So I can debug all the way from the top down. So I can debug everything from, OK, this deployment mapped to this task revision, and here's what changed. That task revision was kicked off by this build number, and that build number was kicked off by this commit. So you can debug everywhere from the commit that triggered the build, that triggered the task revision, that triggered the deployment at the service level. So summits are pretty popular, except in the middle right here, because I think people think that I'll click call on them or something. But we have to scale up our service. So we talked about the desired count. I can scale up and down using just this. And you can automate that based on events or alarms from Cloudwatch. So if I want 4 copies of a task instead of 2, this is all. And ECS will handle scaling them back up, checking to make sure that they're still working, and then I can scale them back down the same way. Same thing that happens. So most people do this through auto-scaling. Ultimately, if you scale up, you don't want to keep the resources going if you don't have the traffic to warrant them, so you want to scale back down. There's a ton of cool stuff, too, that we can do around querying state. So I can describe my service. I can find out the current deployment. I can see what events are happening in my cluster. And then we talked about Cloudwatch, but I can expose those events, right? So I can go back. I can look at the events. I can see what's happening with my cluster. I can see what's going on. And in a lot of cases, I can see, OK, well, maybe my deployment didn't work. Or this is how many copies I have running. So we can find out information about how healthy our cluster is and how healthy our services are by using the API also. So in this particular example, goodbye, London. I promise I'll be back in a couple minutes. But I have to clean up my resources once I'm done using them. So I delete my cluster if and only if I've scaled down my service to have 0 running instead of 4. So without further ado, I'm going to introduce someone who is using ECS in production, Peter Wong from TravelX.
Thank you. Afternoon, everyone. So my name is Peter Wong. I work at TravelX as head of engineering for payments and B2B. So TravelX at a glance. TravelX is the world-leading foreign exchange expert. We've been around for over 40 years. For those 40 years, we've built basically over 1,000 retail stores across airports, department stores, and we've also have around 1,000 ATMs across. So we're handling lots of cash flow in terms of foreign exchanges. And that's the core business of TravelX. So here you see a little history of what has happened with the company. And so right about 2 years ago, we've been tasked to look at how we can actually deliver a lot more digital products for the company. And we're looking at how we can actually build a digital platform that can provide those capabilities. And here it comes engineering at TravelX. And the particular remit we had was actually delivering international payments for TravelX. In fact, setting up a brand new business for TravelX. We want to set up international payments starting from going from UK outbound. And we want to be able to build B2C products and B2B products. In fact, hooking onto as many partners as we can onto a single platform. So we need to be able to deliver those capabilities securely and at scale. What does that mean, securely? So some of you might think about security as end-to-end encryption. But actually, security has not just that. There are other things to consider. For example, compliance. So compliance is a separate topic from security, but we need to take that into account when we build an international payment system, literally an online banking service. So that means we need to be compliant, say, with PCI. We need to be licensed with the FCA in the UK to actually hold digital money for our customer. We also need to be able to resilient. We want our services to be up 24/7. With 0 downtime, even when we're pushing changes to the production. So what does that mean for us then in terms of engineering? What are our challenges? As I said, we want to be able to have encryption of all our data, and that's in flight and at rest. We want full auditability of everything we change, whether it's how we developed our features, how we push that features into our build, how we do release on that surface, and how we deploy it, and how we actually operate it. We want complete auditability. We also want security for traffic coming in and going out of our system. That is traffic coming in from our customer, and for us to talk to our third parties as well. Obviously, as I said before, we want to be able to use it across product, across partners and customers, and this means we need multi-tenancy. We need to be able to support multi-tenant on our platform. So TravelX has other digital products in the existing space. They're not running on the platform, but we want to be able to make use of our capabilities so that we can actually use those capabilities across these platforms or across these products. And of course, as I said before, we want to be able to make changes as regularly, as frequently as we can, because we want to deliver customer value as quickly and as effectively as we can. Hence, we were going through continuous deployment. We have to push changes daily if we want to. We push changes hourly if we want to. And as I said, 24/7 operations. So that means one of the things we turn into is actually, well, let's look at microservices. Why? First of all, microservices, as Abby said, it's a single function. Does it well? It's a black box. You allow polyglot environment. It's composable, so you can actually take one or more of the services you already developed, put together, and there you go, you have a new product. You want to reduce risk. If you're trying to push changes continuously to an international payments platform that's handling money 24/7, you want to reduce risk. And if I can actually check a change, put change into an environment and say, well, actually, I'm actually pushing change to only a very small part, an independent service, that reduces risk. And that actually makes us getting stuff quicker into the market. It also allows us to increase flexibility in development. If our developers comes in, or a new engineer starts with our team, he or she does not need to actually have to know everything in the platform. They can focus on an individual service and actually start developing and adding value to the platform. In terms of operation, flexibility also allows us to say, in terms of security, we can actually partition high risk versus low risk services and have different security posture between those services. And on top of that, we can scale up and down our services independently, individually, as they are needed. So here is an example, actually, what our state looks like right now. We are adding more services as we speak. These services are split between services required to onboard a customer, go through the relevant KYC checks, AML checks, so that they can be our customers, so they can transact with us. There are services here to do with actual payments, so when they're processing transaction, looking at FX rates, also looking at reconciliation and settlement. And there are also these core services that actually is independent of payments, but are services that we need to communicate to our customer. For example, we have an SMS service that actually sends SMS. We have an email service, and guess what? It sends emails. So these services are very much on their own, loosely coupled, and they can be used across many products. So the microservices, we decided to do it this way. But we also want to do it based on some principles so we can actually continue evolving the system. And what we decided to go for is looking at 12-factor app. What are 12-factor apps? So a 12-factor app is an app, a web app that has been developed to follow 12 principles. These principles allow us to be easier to operate the app, easier to release changes to it, to scale, easier to monitor, easier to develop, easier to audit and to secure. So these are the 12 factors on the slide. These are the 12 factors that we need to consider. And I'm going to tell you how we deploy our services and operate them in ECS, how that has helped us to actually fulfill a lot of these principles quite out of the box. So in particular, because we chose to use microservices and choose to deploy them in Docker images, running them as Docker containers in ECS, meaning that our code base, we actually version control our Docker Compose file in source control. We use that to actually establish our audit trail. So every build, every change is actually audited, recorded in source control. And that means also because our deployment unit is a Docker image, all our dependency is actually encapsulated inside that Docker image. We don't need to actually think about our EC2 host, what else needs to be run inside that host. We actually deploy everything is into that image. And the important thing of that is the configuration. Then you can build around that in the forms of environment variables across multiple environments. So as I said, we have continuous deployment pipeline across AWS. So we have 3 environments for our testing, UAT, and production. They're all running the same containers. The only difference is that the environment variables are different. So the configuration drives the difference, the differentiation. At the same time, you can actually run the whole platform on someone's computer if you want to, locally, offline. So I could actually run the platform on an airplane if I want to. And that's the power it gives us by actually setting up the architecture that way. So by using this architecture, we also be able to audit, build, release, and run. And we can do that to push images across our environments. We use port binding to actually allow us to run multiple instances, multiple Docker container into ECS hosts. And these containers, because they are RESTful services actually, they are stateless. What does that mean? That means stateless. They don't contain state. The states are actually transferred onto our database. And that also means these services are disposable. We use ELB health checks to determine the healthiness of these containers. And so if they're not healthy because the host is not healthy, we can reprovision a new host, we can reprovision a new container, and it will be OK because they're stateless. And as I said, dev prop parity. We can develop exactly the same thing as we run in production. So we are very close. The only difference is by a few configurations, such as our SQS queue names, for example. So these are the things that are coming out straight by actually running our estate, our platform on ECS. There are other, as you can see, I haven't highlighted some of the principles, and some of these other principles we actually done by actually came out from the bottom up by design, our architecture. So for example, backing services. So our microservices are built using Java, and we use basically the SDK API as a first principle. So everything is on the API level. For example, let's take an example, queuing. We do asynchronous messages across services, and we use JMS in our service. Now, we're not going to talk to SQS when we actually run our services locally. So what do? We use ActiveMQ as an option just for local development. That is fine because our code is actually agnostic to which implementation we use. We just happen to be switching them under the hood. On top of it, it's still talking to JMS. So that's an example of how we treat our backend service exactly the same way. And at the same time, the traffic going through from the services to the backend service are fully encrypted as well. And I'll pick another example, logs. Logs is very important here. We have so many services running on ECS. We actually use centralized logging. What we actually use in our Docker logging driver is a Cloudwatch logging driver that allows us to send our logs from standard out all the way to Cloudwatch directly without touching the host. And that means we're actually saving IOs, and also it means that we kept all our logs eternally and using Cloudwatch. And then when feeding that into Elasticsearch, and we use Kibana to be able to visualize and analyze those logs. So here is a high-level view of how we actually provision our services. As you can see, we use a number of AWS services. We use cloud services like SESQ, SNS, SES, and S3 object store. We also have CloudFront to use as our CDN. Coupled with our WAF, which defines our WAF rules to allow traffic coming in. We have an API gateway in the form of an Nginx that allows us to act in a reverse proxy to allow us to actually surface the request and to decide on where that request will go into our ECS cluster. As you can see, we also have using RDS. As underneath it, we use Postgres to actually host our transactional data. So here is just a more example of how we actually do end-to-end encryption. So if a customer, whether it's an end user or a partner, it talks to our API either through a website, and that will be fully encrypted. With a partner, it's actually using TLS mutual auth. That goes into a public-facing classic ELB, actually sitting on top of our Nginx cluster. So these traffic will flow through because at layer 4, they don't actually have to decrypt at the ELB layer. They go straight into Nginx. That gets decrypted and re-encrypt using the key within Nginx. And then we actually do mutual auth between our API gateway and our services. And all our services actually in a private segment, so their ELB is private-facing. And all our PKIs is managed by Hascope Vault, which we use actually as a service as well as a RESTful service. So everything in that cluster pretty much acts as a RESTful service. So let me give you an example of a service we have and go through that flow in a bit more concretely. So we have a rate service that literally allows you to retrieve rate. That rate could come from a database because we want it to be cache, more indicative, and more efficient. We want to minimize the number of hops. or it could be talking to an internal system over a network. And then as a business logic, we want to apply some logic in the business logic, and then return back to the user. So if you look at our flow, basically a customer hits our website asking for a rate. It goes into CloudFront, and then that will direct that traffic into the public-facing ELB, to our Nginx gateway, and then that goes to the private ELB of that particular service, and hits our service running as Docker containers ECS, and then it talks to a third party. The third party, as I said, it could be a database, or it could be something within another system outside of Amazon. And that's it. What I've got to say. Thank you.
Thank you so much, Peter. So a couple of housekeeping things. And the first one is, what was my kind of initial takeaway when I was working with microservices, and I think that's what I got from Peter's too, is that there's a deceptive amount of work that kind of goes into doing these and doing these well. So you have things like the 12-factor app that helps you kind of figure out, OK, well, here are the things that I need to focus on. But I think beyond that, there's a lot more pieces than a lot of people think. And I've gotten some questions where people are like, oh, well, I had my monolith, and I put the whole thing in a container, and now I hate it. So it doesn't work. I'm not getting any benefits out of it. And you're right. If you just take your monolith, your existing code base, and you shove it in a container, and you say, well, this is it, you're probably not going to get a whole lot of benefits out of it. So part of this process, so part of moving from this monolith to microservices, and you get a lot of articles from people that are like, oh, well, I did ECS in a weekend. I set up everything in a weekend. And if you go from a totally greenfield situation, right, where you're setting up a whole new product, a whole new service, a whole new company, it can be really easy. It's pretty natural. There's a lot of resources out there to help you. But beyond that, that's not how everyone comes. That's not where everyone comes from. People are coming from existing apps. They're coming from extensive existing apps. So part of that is how can I break down my monolith in a way that makes sense? So how can I go from this one big piece to all of these little pieces in a way that they speak to each other correctly, they have the right service focus? So how do I do that? And I think it's really valuable to hear from people like Peter and from TravelX who have been able to do this in real life with their real data, and they're still taking money. And people take their money really seriously. So definitely a lot of work that goes into kind of keeping these things up and making them work really well. I think it's the same thing that I said about flexibility, though, right? Is that you should be able to kind of run things out of the box without thinking about it and focus totally on your app. But you should also have, from whatever orchestration platform, the choices to kind of be flexible and extend your platform on top of that to make sure that ECS can run your workloads the way that you want to run them. Couple housekeeping things. One, limited time for questions because we're kind of switching things over to the next speaker. Both Peter and I will be happy to kind of hang out for a couple minutes afterwards during the break to answer any questions. I did look at Twitter, and I guess Werner promised everyone that I would make a Wu-Tang joke. So I don't have a Wu-Tang joke. So I solemnly swear that I will tweet a Wu-Tang joke in the next hour. But apparently I've set the bar for corny hip-hop jokes too high for myself. That is all. Thank you so much. There's a ton of resources online if you want to look at some of these reference architectures. So for those of you that were furiously taking pictures, the slides will be posted. Thank you very much.